Now we're going to use the properties of the different special parallelograms to find measures, solve for lengths, that kind of thing. When we're doing these types of problems, the first thing that is important to do is identify which of the special parallelograms we're using and which of the properties apply to that one. Okay, so for this first one, I see that I have a rhombus. So rhombus is equilateral, all the sides are the same. The diagonals are also perpendicular, and then all of the properties of parallelograms apply as well. Okay, so what can we fill in? We've got BCA is already labeled at 44, AB is 9, and AE is 7. We're looking for each of these. So BC is a side of the rhombus, and because I know that it is equilateral, I would strongly recommend you mark all that, okay? That things are congruent here. Because it's equilateral, then that means BC is 9. Okay, AC is the length of a diagonal. Well, I know that this part is 7, but because diagonals bisect each other, these two have to be congruent. So EC is also 7, therefore AC is 14. Make sure you don't just say, oh, it's 7 because they're the same. Pay attention to what you're looking for, okay? ACD is this angle right here. Okay, we're looking for ACD. And because the diagonals are bisecting the opposite angles, that means BCA and ACD are congruent. So this one is also 44 degrees. ADC is this angle right here. Now, all four angles are not necessarily, congruent on a rhombus, only if it is also a rectangle. So we cannot say, oh, well, if these two are 44, these two are 44. But remember, for parallelograms, the consecutive angles are going to be supplementary. So if this whole thing is 88, twice 44, then this angle, okay, I'm going to make 2 lines here, this angle right here is going to be 180 minus this. So 180 minus 88 is 100 minus 8, which is 92. So ADC is 92 degrees. Then ABD, well, ADC is congruent to that. So this one is also, the whole thing is 92 degrees, but I can cut that in half again because diagonals are bisecting angles. So half of 92, half of 90 is 45 plus 1. So is 46. And then DEC, because it is a rhombus, the diagonals are perpendicular to each other. So that one is 90 degrees. Okay, so you notice as I was answering these, I was saying because of this property, that's how I know these different relationships. Okay, continuing, here we have the diagonals of rectangles EFGH. Because it is a rectangle, I know that it is equiangular, so all 4 angles are right angles. And then in addition, the diagonals are going to be congruent, okay, plus all of the properties of parallelograms. So HFG already labeled as 31. EG, let's see, EG is not labeled here. The total, that's the whole diagonal here. It's hard to label diagonals because they intersect at a spot. So whole thing here is 17. All right, EFG, EFG, because this is a rectangle, that is 90 degrees. And then EFH is just looking for this part up here. And because we have a right angle there, we can do 90 minus 31. 90 minus 30 is 60. Minus 1 is 59. And then for FHG, so that's looking for this one down here. Okay, parallelogram, remember, those properties still apply. So because the opposite sides are parallel with this transversal, this is what I'm looking at, these 2 lines plus this transversal, I have alternate interior angles congruent. So this one is the same as EFH that I just found. FHG, making sure I was looking at the right one. Okay, so this one is also 59. And then HF is this diagonal, which is congruent to the other one, so 17. Okay, continuing, here we have a square, so all of the properties of parallelograms and rectangles and rhombuses apply. Okay, this says that MK is 1/2 and LP is 1/4, but that's an impossible square, so that doesn't really make a square with those links, so ignore that. We're going to change this and say that MK is 3 root 2 and LP is equal to 6. Okay, now it works. So this is 6, and we're going to make this a 3 root 2. Because we have 4 right angles, because it's a square, like this is a right angle, and all of the sides are the same. If this is 6, this is 6. The Pythagorean theorem says that MP, the whole thing, has to be root 2 times this, like 6 squared plus 6 squared, and then take the square root. So this would be 6 root 2, so that's only 3 root 2. With those two numbers, somebody made those up and it actually doesn't work. Okay, so let's use these numbers instead. All right, so what is PK? PK is the length of half of the diagonal. It's a parallelogram as well, so diagonals bisect each other. Okay, so this is the same as this. So this is 3 root 2. LM, it's equilateral, so LM is 6. LN is the total length of the diagonal, so 6 root 2, because we have the same length as this one, 3 root 2 plus 3 root 2. And then for the measure of angle PKN, okay, so squares are also rhombuses, meaning diagonals are perpendicular, so that is 90. And then measure of LMN, okay, it's also a rectangle, so this is 90. Right? And then MNK is this angle right here, because on a rhombus the diagonals bisect the opposite angles. I'm taking this angle of 90 and cutting it in half to get 45. Okay. Continuing on, same thing, we're looking at whatever type of figure we have. Now here it doesn't tell us, we're going to have to identify that from the figure. And then we're going to use those properties to write an equation and solve for x, okay? It does tell us to explain our reasoning, so I'm not going to write out like a full proof, but I am going to write some justifications. So I have that Wx is 14 plus 3x, that's this length here, 14 plus 3x, and xy, this length, is 1 minus 10x. So here, if I want to know what type of quadrilateral it is, I'm noticing that these 4 marks make it equilateral, and these 4 marks make it equiangular. So if it is both, then we have a square, both equilateral and equiangular, or both a rhombus and a rectangle. Okay, so we're going to say WXYZ is a square, and I'm going to say it's equilateral and equiangular. Whoops, forgot the U. Okay, both of those. Sorry, there's a little blip there. I had to pause. Okay, so because it's a square and because they're marked congruent, I can set these two equal to each other. So I have 14 plus 3x is equal to 1 minus 10x. I'm going to move this over. So I have 13x equals negative 13. So x is negative 1. That should be a little bit of a flag just because usually we don't have negative values for variables. It doesn't mean that we can't, most of the equations that we have are not. But let's double check, is it okay that x is negative 1? If I plug it back in here, I get 14 minus 3. Yep, that's fine, it's 11. And if I plug it in here, I get 1 minus negative 10, if I'm multiplying the 10 times negative 1, which is 11. So in this case, yeah, x is going to be negative. Usually I would like you to kind of have a little bit of a, like, oh, I need to check something whenever you get a negative value for x. That doesn't mean you can't have, like, don't say, oh, I did something wrong, but just pay attention to that, okay? All right, moving on, this one right here, all 4 sides are marked congruent, so this is a rhombus. I don't know that the angles are right angles, so I'm going to say WXZY. Yeah, okay, going in order. This one, the letters were alphabetic. Okay, WXZY is a rhombus because it's equilateral. Marked with all sides congruent. Okay, so then WAX is 90 degrees. Okay, So I can use that to solve for y. And then WZY is this angle right here, which is 40, and WXY, this one is marked as 4x. Okay, so let's get some relationships here. First of all, I'm going to start with this one. I know that WAX is equal to 90 degrees, so I can set this equal. I'm going to add 8, so 2y equals 98, so y is equal to half of 100 would be 50, minus 1 is 49. So y is 49, okay? And then because it is a rhombus, let's see, the diagonals are bisecting opposite angles, so we can use that to fill in a little bit more. If this is 40 degrees, this one is also 40 degrees. It's kind of small, make it bigger. This one is also 40 degrees. So if this is 80 degrees, not drawn to scale, then this one needs to be 180 minus that. It's a parallelogram, so they're still supplementary, okay? So 180 minus 80 is 100 degrees. Okay, so this whole thing is 100 degrees, meaning that half of that, because we're bisecting, 50 degrees is the 4x. Okay, so 4x is equal to 50 degrees. So x is equal to 50 over 4 is 25 over 2. Or 12.5 if you want to do it with a decimal. Okay, so there's x. For that one right there, if you want to try and write the whole thing in one equation, like instead of filling in the parts in between, it just depends if you like to write one big thing and solve it or fill in little things. But I would do 2 times 40 plus 2 times 4x is equal to 180. So I did, if this is 40, 2 times 40, so 2 40s there, plus 2 4x's has to be 180 because these two are supplementary, okay? And then from here you can solve, you will get the same thing because that's 80, subtract 80, divide by 8, 100 divided by 8 is the same as 50 divided by 4, okay. All right, one more. Find the lengths of the diagonals of WXYZ. I don't have it, I'm going to draw it. It does tell me the order of the letters based on that. So WXYZ, and I don't really know what it's going to look like, so I'm just going to draw kind of a generic quadrilateral here. So WY, hold on, WX, please label the point so you know which measures they're giving you. So WY is 3x plus 4. That's this one right here. So it's a diagonal, is 3x plus 4. And then ZX, the other diagonal, is 4x minus 1. Okay, because it is a, oh, never mind, it did tell me rectangle. Sorry. Because it told me it was a rectangle, I know that the diagonals are congruent. So 3x plus 4 equals 4x minus 1. Subtract 3x's, add 1, and I get x equals 5. Now, here I am not done, so pay attention to the wording of the question. This one says we are looking for the lengths of the diagonals. Okay, so I'm not just solving for x. This is one of those things where we finish, we get x equals and we feel like we're finished, we move on, but pay attention. We're not quite done. It does ask us what are the lengths of the rectangles. So I can take the 5, it doesn't matter, plug it back into one of those. So 3 times 5 plus 4 is 15 plus 4, so 19. And we can double check. 4 times 5 minus 1 is also 19. So yep, we solved correctly. Okay, so big thing here, as you are writing your equations or as you are filling in missing segments, pay attention to what type of special parallelogram it is and use that to get your relationships, okay? If you don't have the relationships memorized yet, then you should have your chart out from the beginning of the notes as you are doing these so you can say, oh, it tells me it's a rectangle. That means, and then look at those things, etc. Okay?